Welcome, Mr. Sutton, with the IM3 Honors 4-5 Extra Practice #1 solutions on graphing quadratics. To graph this quadratic in standard form, we need to find the vertex first. So that'll be negative b over 2a to get the x value of that vertex. We have a b value of -4. That's the coefficient of x. So we have -4 over 2 times, now the a value is an invisible 1 out in front of that x squared. So this is 4 over 2, which is 2. And now to get the y value of the vertex, we plug that back in for the x up here. So we've got 2 squared, which is 4. We're subtracting 8 from that, so that's -4. Plus 6 gives us a +2. So our vertex then is 2, 2. And let's just go ahead and graph that here. So that's right there. Now we can also get the y-intercept out of this. This is the c value, this constant out at the end here. So that's 0, 6 for the y-intercept. And that's going to be up here. Now the axis of symmetry goes through this vertex here. So just using symmetry, if we have a point that's 2 to the left of that axis of symmetry, then we have a symmetrical point that's 2 to the right in the other direction there. And now we have 3 points to graph the parabola. To graph this parabola in intercept form, let's get the zeros first. So that's going to be whatever zeros out each of these factors. So that's going to be x equals 0 for this first factor of -2x. And then for this x minus 2, that means x equals 2 is another 0. So these x-intercepts here, let's graph those out. We've got 0, that's the origin there, and then 2. And now to get the vertex, we're going to average these together. So that's 0 plus 2 over 2. That's 2 over 2, which is just 1. So that's the x value of the vertex. To get the y value of the vertex, we plug that back into the original formula here. So -2 times 1 times x, or times 1 minus 2. So this is just -2 times -1, which is +2. So that means we have a vertex of 1, 2. And going back to graph that, 1, 2 is right there. And we can draw the parabola now through those 3 points. And if we take a look, this is a negative out in front, so that means our parabola should open upside down, which it looks like it does. For this problem, we're trying to graph a parabola in intercept form. So let's start by finding the x-intercepts, or zeros of this. To do that, we just set this equal to 0 and solve for whatever's going to zero out each of these factors. For this first factor, x plus 3, x equals -3 would do the job. And for the next factor of x plus 5, we have x equals -5. So graphing those out, we have -5, -3. And now we need the vertex. To get that, we can average the zeros together. So -3 minus 5, or plus -5, over 2. That's going to be -8 over 2, which is -4. Now we plug that back into the equation to get the y value of the vertex. So we've got, let's see here, -4 plus 3 is -1. -4 plus 5 is +1. -1 times 1 is -1, times the 2 out there is -2. So we have -4, -2 for the vertex. So that's going to be back 4, down 2. And then draw the parabola through those. And just looking at this here, it looks like it should open up because this is a positive out in front, so we are done. For this problem, we're graphing a parabola in standard form, so that means I'll start by finding my vertex using the x value of the vertex equals -b over 2a. So let's see here, our b value is -4, that's the coefficient of x, so we have -4 up top. Down below, 2 times a, that's going to be 2 times this -2 here. So we have +4 over -4, which is -1. Now I need the y value of the vertex, which I can find by plugging -1 back in for x in the equation here. So let's see, -1 squared is going to give me 1, times -2 is -2. And -4 times -1, that's going to be +4. So we basically have -2 plus 4, which is +2. And then -1, that's going to be 1 left over. So -1, 1, that's going to be our vertex, and that is right up here. Now, to get 2 other points, I'm going to get the y-intercept. That's this constant out here, this -1. So we have 0, -1 for the y-intercept, and that is down here. And now using symmetry, since x equals -1 here is the axis of symmetry, that means if I have a point 1 to the right of the axis over here, I can go one to the left in the other direction to this symmetrical point, put a point there, and now I have 3 points for graphing that parabola. On this one, we're trying to graph this quadratic that's in standard form. So for that, let's start with finding the vertex with negative b over 2a. b is going to be this 2 coefficient of x, so that's negative 2. A is this 1/2 coefficient of x squared, so that's 2 times 1/2 down there. So let's see here, 2 times 1/2 is really just 1, and negative 2 divided by that just comes out to negative 2. So we have an x value of negative 2 for the vertex. To get the y value, we plug negative 2 back in the original equation. So we have 1/2 times negative 2 squared plus 2 times negative 2 plus 4. Negative 2 squared is positive 4. Half of that is 2. So we have 2, and this is going to be minus 4 here. So 2 minus 4 brings me to negative 2, and the negative 2 plus this last 4 over here gives me positive 2. So we have negative 2 comma 2 for the vertex, and that's going to be right about here. And now to get 2 more points, I can find the y-intercept. That's this constant out here, this c value of 4. So that's a y-intercept of 0 comma 4, which is up here. And then using symmetry, the axis of symmetry goes through this vertex right here. So if I'm going 2 to the right from the axis of symmetry, I can go 2 to the left in the other direction to get a symmetrical point right there at negative 4 comma 4. And then I can just draw the line, the parabola, through those 3 points, and I'm done. To graph this parabola in standard form, let's start by getting the zeros. Those are going to be negative 1 for that first parentheses, and negative 3 zeros out that second parentheses. So those are our x-intercepts. So we've got one at negative 3 and also negative 1. Now to get the vertex, which we always need to graph, we average these together. So that's negative 1 plus negative 3 over 2. That's negative 4 over 2, which gives us negative 2. That's the x value of our vertex. Now we plug that back into the original equation to get the y value. So we've got, let's see here, negative 2 plus 1 is negative 1. Negative 2 plus 3 is positive 1. Negative 1 times positive 1 is negative 1. But we have a negative out in front of all this, so that flips back to being positive 1 after all that work. So then negative 2 comma positive 1 is our vertex, and that's going to be right here. And now using those 3 points, we draw the parabola. On this problem, we have a standard form quadratic. So to graph this out, we're going to start by getting the vertex using negative b over 2a. b is negative 2. It's the coefficient of x, so that's negative negative 2 up top. For a, we've got actually a negative 1 here. That's what negative x squared means. So 2 times negative 1 down there. So we've got positive 2 over negative 2, which comes out to negative 1 if we reduce that. There's the x value of our vertex. To get the y value, we have to plug that back into the original. So we have negative negative 1 squared minus 2 times negative 1 minus 4. Negative 1 squared is positive 1, but then it flips back to negative with this negative out here. So we have negative 1 plus 2 gives me a positive 1, and 1 minus this last 4 gives me a negative 3. So then my vertex is negative 1 comma negative 3. So negative 1, negative 3 is right there. And now for my other points, I can get one with the y-intercept. That's this constant negative 4 here. So that's 0 comma negative 4, which is right here. And then since we have an axis of symmetry going through my vertex, if I'm going 1 to the right of that imaginary vertical line for 1 point, I can go 1 to the left over here to get a symmetrical point. And now I have 3 points to graph my parabola.